Alright, here's a demonstration of the speaker that I made during the lab. Right now the frequencies are very low and it is not audible, but you can see the speaker vibrating up and down. Sorry for the background noise.
20 hertz.
These frequencies are in the 1 kilohertz range.
No, but I guess I got it. It's fine, though. The lab report itself is so
And these frequencies are in the 10 kilohertz range.
Piercing.
Okay, so now I'm going to try and reconstruct the speaker that I made during the lab, while also trying to make some minor improvements so that it can hopefully sound a little bit better. We're going to be using these neodymium magnets that I have, which are 3 centimeters in diameter. Okay, now the first thing I'm going to do is create the cone out of paper. I'm using this circular object to trace the cone out. Note that I'm using 2 layers of paper which I'm going to glue together in order to make the cone a little bit more rigid. And here it is all cut out. It looks pretty good. Okay, now I'm going to try and make the voice coil, which will essentially be a bunch of coils wrapped around a paper cylinder. I just need to find out how high to make it. It looks like the magnets are 3 centimeters high, so I should be good with making it 4 centimeters high. Now I'm just wrapping the paper strip around the magnets to create the cylinder and gluing it in place. I'm going to be using this first cylinder as a spacer for the actual cylinder, just to provide enough of a gap between the voice coil and the magnets for it to slide up and down easily. Now that it's done, I'm just going to see if it slides up and down pretty easily, and it seems to do so even with the spacer still in. The next step is going to be to wrap the copper wire around the cylinder, and to do this I'll be using hot glue to secure it in place. Okay, here's the finished product. Note that I did 2 loops of wire, one all the way down and then back up. Since the more loops we have, the stronger the current-induced magnetic field will be, and it does slide up and down easily, which is good. Alright, now I'm going to try and make the spring mechanism that will be attached to the cone and allow it to move up and down easily. I'll try to do something similar to what I did in the lab with the folds of paper. And here's the spring mechanism. These will be attached to the cone using some tape. And yeah, the cone will just rest on top of these, like so. And now I just need to make the cone more into a cone instead of just a flat piece of paper. And that looks pretty good. Now I'm just attaching the springs to the cone. I just need to make sure that it is all lined up. The next thing that I'm going to do is glue the voice coil to the cone using hot glue as well. And here's what it looks like. Note that I can always adjust the spring tension by stretching out the paper or compressing it. Now the real test is to see if it will slide up and down over the magnet, and it seems to be good as well. Now we can move on to making something to attach the cone to, which I'm just going to make out of popsicle sticks. And so this is what I've made. I cut the popsicle sticks so that when the cone is attached, the voice coil should sit just above the magnets. Now I'm just gluing the cone to the stand using hot glue, and this is what it looks like all done. And that test if it will slide over the magnet easily, and it looks good. Also, it sits just above the magnets. So now we can move on to testing. Okay, to test the speaker now, I'll try to play some music off of my computer. And to do this, I'll use this headphone cable that I cut open to expose the interior wires. And as you can see, there's 3 interior wires. I think this is the ground, and then the left and right outputs. And if I hook up like one of the ground and one of the outputs, to these copper wires, it should work. Just plug it in and take the magnet and try to position the cone so that it is directly over the magnet. That looks pretty good. Okay, now that the wires are hooked up, we can go ahead and play some music. Just know how to use the box to prop up the wires, and the cone can move up and down easily. So it should work right after this ad. As you can hear, it is playing music. And essentially what is happening right now is voltage is applied, which induces a current through the wires, and due to the BSFR law, this produces a magnetic field which interacts with the permanent magnetic field from the magnets. And the magnetic field induced by the wires can be determined by the right-hand rule. And this magnetic field, if the poles are the same, they would again repel, and if they're the opposite, they would attract. And this can cause the cone to move up and down, which then vibrates the air, which we interpret as sound. And if the current switches many times a second, it can vibrate the cone at different frequencies, hence producing the music. Just for reference, if it'll ever focus, this is what my laptop speakers sound like. So yeah, this sounds like what you would expect a paper speaker to sound like. Yes, anyways, thank you for watching. Hope you enjoyed.